In this examination of index laws, we're going to look at what happens when you have a number which already has an index with another index. So for example, let's take a look at 7 squared all to the power of 3. This is 7 squared times 7 squared times 7 squared, expanding only to just one level. Using our multiplication index law, this is 7 to the power of 2 plus 2 plus 2, which is 7 to the power of 2 times 3, which is 7 to the power of 6. So we have the index law where a to the power of m all to the power of n is a to the power of m times n. Example, 5 to the power of 2 all to the power of 3 is 5 to the power of 2 times 3, which is 6. 4 to the power of 5 squared is 4 to the power of 5 times 2, which is 10. T to the power of 4 squared is t to the power of 4 times 2, which is 8. And q to the power of 7, all cubed, is q to the power of 7 times 3, which is 21. In this part of the video, we're going to look at what happens when we've got two numbers, the product of two numbers, and that is then raised to an index. So for an example, let's take 2 times 3, all raised to the power of 4. In expanded form, this is 2 times 3 times another 2 times 3 times another 2 times 3 times another 2 times 3. Now you know that multiplication is what we call commutative, which means you can do it in virtually any order. So let's arrange our 2's together and our 3's together. Now, from this expanded form, we're going to look at all the 2's, and we're going to write the 2's as 2 to the power of 4 and 3 to the power of 4. This gives rise to our next index, which is a times b all to the power of m, is a to the power of m, b to the power of m. So, for example, 5 times 6 all cubed is 5 cubed times 6 cubed. 37 times 49 squared is 37 squared times 49 squared. R times t all to the power of 6 is r to the power of 6, t to the power of 6. Q times y to the power of 4 is q to the power of 4, y to the power of 4. You've just seen the development of two index laws. Those were that a times b all to the power of m is equal to a to the m, b to the m. And the other one was that if I've got something like a to the m and all of that is raised to the power n, then that's equal to a to the m times n. So those are our two laws. Ironically, when we're working in a bit more of the real world, these two don't get used separately. They sort of get used together. I'll give you an example. Suppose we have 3 squared a cubed all to the power of 4. Then this law allows us to bring the index in and apply it to each of these. That will be bracketed, so that will be 3 squared all to the power of 4, a cubed all to the power of 4. So I've used this law, and then I use this one to bring these indexes back inside here. So this becomes 3 to the power of 2 times 4, which is 8, a to the power of 3 times 4, which is 12. And you can see we could have gone from that straight away. So that's what we'll be doing. It makes life so much easier. You don't have to worry about putting that step in. Go straight from there to there, because you can use both of these simultaneously. Let's now take a look at some further examples. The example I just ran through pretty well covers everything. So let's take a look. Let's suppose I've got 2a cubed b 5 q to the 7 all cubed. We can take this inside, so we've got Remembering that this is really 2 to the power of 1, so we're going to have 2 to the power of 3 times 1, which is 2 to the power of 3. A to the power of 3 times 3, which is 9. B to the power of 3 times 5, which is 15. And Q to the power of 3 times 7, which is 21. Okay, so that's one of our examples. Let's do another one. Suppose I've got 2a cubed b squared all to the power of 4. Now in this example, you'll notice that the 2 is outside the bracket, so that index doesn't get applied to it. So that stays as 2. Then we take this inside, so a goes to the power of 3 times 4, which is a to the power of 12. For b is b to the power of 2 times 4, which is 8. And that's it. The important thing here is whatever's outside the brackets doesn't get raised to that power. Let's take a look at what happens if we have 2a squared b cubed to the power of 3. This is a two-step process. The 2a squared is outside the brackets, does not get affected by this power here. Now we bring this one inside, so we're going to now have an a to the power of 2 times 3, which is 6, b to the power of 9. Now we've got something where we've got a's here and a's here, so now we'll resolve those. We're using the multiplication law. A to the power of 2 times a to the power of 6 is a to the power of 2 plus 6, which is 8, times b to the power of 9. Done. Key point, this only applies to what's inside the brackets. Consider the following example. 2 cubed a squared all to the negative 3. Still works exactly the same way. You multiply the indexes. So here we've got to have 2 to the power of 3 times negative 3, which is negative 9. A to the power of 2 times negative 3, negative 6. Done.